Okay, so in this video we're looking at question 39 of the Caringbah 2020 trial. A particle is moving in a straight line. At time t seconds, it has a displacement x meters from a fixed point O on the line, velocity v meters per second, and acceleration a meters per second squared, as given by a is equal to 6t minus 12. Initially, the particle is at rest at O. Now, this line here is really important. It pretty much just tells us at t is equal to 0, not only is it at 0, at O, so the displacement is 0, the velocity is also 0 because it's at rest. Okay, so that one small line gives us a lot of information. Find the expressions for v and x in terms of t. So if acceleration is equal to 6t minus 12, then the velocity has to equal to the integral of that. So we're going to integrate this. When we integrate this, we will get 3t squared minus 12t plus c. Now, when t is 0, v is 0. So 0 is equal to 3 lots of 0 squared minus 12 lots of 0 plus c. And now we can confirm that c is equal to 0. So that means that the equation of the velocity has to be 3t squared minus 12t. Okay. We've done that first part. We've found the expression for v in terms of t. Now, in order for us to work out displacement, we need to integrate the velocity with respect to t. So what do we get when we integrate this? We get t cubed minus 6t squared. I'm going to write plus d, okay, because we've already used c as a constant. And now, when t is 0, x is 0, because it's at the origin. So 0 is equal to 0 cubed minus 6 times 0 squared plus d. And so now we can also confirm that d is equal to 0 as well. Okay, that the constant is just 0. So therefore, the displacement is equal to t cubed minus 6t squared. Okay, part B, find when and where the particle is next at rest. So at rest means velocity is equal to 0. So what I'm going to do is I'm going to make this equation, velocity is equal to 0, and I'm going to solve to work out what the times are when the velocity is 0. So at rest, let me use blue. At rest, when velocity is equal to 0. So we've got 0 is equal to 3t squared minus 12t. Just going to factorize this. 3t bracket t minus 4. And therefore t has to equal to 0 or 4. Well, we already knew that it was at rest at t equals 0 because of the question. So the next time it's at rest is at t equals 4. Next time the particle is at rest. Okay, and that's 4 seconds. Let's just double check that. Yep, time t seconds. So that's 4 seconds. And so we want to know, we found when it's at rest, but where is the particle? Okay, that's what we actually need to work out as well. So when t is equal to 4, where is it? What is this displacement? So we can sub that into this equation and see what we get. 4 cubed minus 6 lots of 4 squared. Negative 32. So what does that mean? It means that the particle is next at rest 4 seconds later. It is 32 meters to the left of the origin. O. Okay, left because it's negative. If it was positive, it'll be to the right.